All right, here we have another logic problem, which is asking us to write an Euler diagram to represent the statement, if you are 19 years old, then you can vote. Okay, an Euler diagram is usually represented by a rectangle and a circle. It is supposed to represent each part of the diagram based on the size of the statement, so to speak. So the group of 19-year-olds in America is much smaller than the people that can vote. So in terms of this diagram, the box is much larger than the circle. So we're going to say the people that can vote go in the box, and the people that are 19 years old go in the circle. We can use this diagram to evaluate the statement, if you can vote, then you are 19 years old. People that can vote are anywhere inside this box. People that are 19 years old are only inside this circle. So I would have to say that this statement is false due to the fact that this X right here can represent someone who can vote but is not 19 years old. So it is not true that if you vote, then you have to be exactly 19 years old. The next problem asks us to come up with a valid conclusion for these statements. I think it's always easier to turn them into logic symbols. So I'm going to say if a triangle is equilateral, meaning I'm going to call that T, then, because the arrow represents if-then statements, the triangle is equiangular. I'm going to call that E. Then we know that the triangle is, in fact, equilateral. That would be my T statement. So based on the modus ponens law that you learned, if you have an if-then statement, and the first part of the if-then statement is true, then you can conclude that the second part of the if-then statement is also true, which in this case would be E. And in words, that is, the triangle must be equiangular. The next statement says, if Sally studies for the test, I'm going to say that's S, then she will pass the test. That's going to be P. She does not pass the test. All right, there's a law of logic that says if the conclusion of one statement is in fact false, then the premise of that statement is also false. That's the modus tollens law. In our case, that would mean our conclusion has to be not S, the opposite of the first premise.